Welcome to This Explainer. Today, we're diving into the absolute ultimate houseplant whodunit, diagnosing mysterious plant decline, and honestly, we're going to focus squarely on the number one culprit in the entire horticultural world, moisture imbalance.
Seriously, we have all been there, right? You're staring helplessly at a favorite suddenly drooping plant, and you're just wondering, is it begging for a drink or secretly drowning in it? You give it light, you give it love, but it still looks absolutely miserable. What's going on?
Well, the investigation is tricky because of a specific concept, distal reflections of root zone pathologies. I know, it sounds super academic, but it basically just means that the above-ground symptoms we see, the wilting, the yellowing, they're merely distant clues. They're pointing to a hidden subterranean crime scene taking place way down in the root zone. And this perfectly illustrates the central paradox we face as plant detectives. The symptoms for both overwatering and underwatering, they're deceptively identical. Lower leaves turning yellow? Yeah, could be either. Little to no new growth? Both. Brown margins and wilting? You guessed it, both. This happens because both conditions ultimately result in a loss of turgor pressure within the plant. So how on earth do we tell them apart? That brings us to Section 1. Drowning versus desiccating in moisture imbalance. Let's just dive right into this and separate our two primary suspects to understand what's actually happening inside that vascular system. So physiologically, the responses are actually very different once you look closely. Think about it. An underwatered plant desiccates. Its cells lose pressure and it essentially curls its leaves upward or inward. That's a defensive mechanism to reduce the surface area available for transpiration. The leaves are going to feel thin, papery, and crispy. Now contrast that with an overwatered plant. An overwatered plant suffers from hypoxia. Saturated soil means the air pores are filled with water, which literally suffocates the roots so they can't perform cellular respiration. Since they can't take up water, the plant wilts, but the leaves curl downwards. They feel soft and limp, all while sitting right there in a puddle. Now, it's fascinating how this physical evidence manifests. Take marginal leaf browning, for example. This can totally happen the first time a plant gets too dry, as those outer edges just dry out. But, and here is the kicker, it also happens when drowning, rotting roots completely fail to deliver water upward. The tissue dies because it's simply not getting moisture, even though the pot is soaking wet. It's a classic sign of water stress regardless of the initial cause. Okay, moving to Section 2, the disease triangle, a foundational rule. The crucial point here is that improper watering doesn't just cause physiological stress. It actually turns your plant into a super vulnerable target for secondary infections. This brings us to a foundational rule of plant pathology, known as the disease triangle. Basically, an infectious disease doesn't just happen by chance out of nowhere. It can only take hold if you have all three sides of the triangle aligned: a vulnerable or stressed plant, an active pathogen, and a favorable environment that supports the attack, like, say, soggy, waterlogged soil. If any one of those sides is missing, the disease just cannot fully develop. To build our case, let's look at some physical evidence. A wet, dark, water-soaked lesion on an orchid. This right here is the perfect evidence of an opportunistic pathogen taking full advantage of an overly wet environment. The host was stressed, the bacteria were already present, and that high moisture provided the absolute perfect breeding ground. See, when the soil stays consistently soggy, nasty pathogens like Pythium or Phytophthora invade the oxygen-starved roots, causing root rot. And it gets worse. Vascular wilt fungi like Fusarium can actually enter through the roots and colonize the xylem, which is essentially the plant's internal plumbing. As the fungus multiplies and the plant frantically tries to fight it, the xylem becomes completely clogged. The result? Your plant's water supply is entirely cut off, meaning it literally wilts to death while sitting in a pot full of water. Crazy, right? All right, Section 3, subterranean diagnostics. Look below the surface. We know what we're up against, so it's time to pull out our diagnostic tools and gather the physical evidence. Before you do anything drastic, try the screwdriver test. It's incredibly simple but highly effective. If you push a screwdriver into the soil and hit hard, compacted resistance within the top 6 inches, it means physical restriction and poor oxygen diffusion are actively suffocating the root system. This compaction prevents water from draining properly and literally stops the roots from breathing. You can also perform a root excavation to check for rot. Sometimes we use what's called the white paper test to really see the contrast. Healthy roots in most houseplants, they should be firm and light-colored. But rotting roots, yeah, they will be dark,
mushy, and the outer layer, the cortex, will easily slide right off under light pressure, leaving behind just this stringy central vascular thread. If you see that, well, you found your culprit.
Now, a quick warning about rookie reactions and red herrings. When you see a yellowing leaf, please, whatever you do, don't impulsively dump nitrogen fertilizer on it in a panic. As we've seen, these symptoms are almost always a moisture or environmental imbalance first. Adding random fertilizer can cause saltburn, which makes the leaf curl and browning even worse. Also, keep in mind that edge browning on sensitive plants can sometimes just be a reaction to chlorine or fluoride in your tap water. So always rule out watering issues before you feed.
Section 4, Fixing the Flow, Solving the Mystery. Now that we've ruled out the red herrings and identified the true cause of the stress, how do we actually solve this mystery and fix the flow of moisture? Just simply follow these 3 diagnostic steps before you water. First, physically feel the soil moisture 2 to 3 inches down with your finger or use a moisture meter. Only water when it feels slightly dry. Second, inspect the root ball. Don't be afraid to gently slide the plant out of its pot to check for compaction, root rings, or rot. And third, check your room's environment. Are there cold drafts? Is the humidity too low? You generally want to aim for over 40% humidity for most tropicals. So the next time you encounter a wilting houseplant, the mystery is yours to solve. You now know that the above-ground symptoms are just clues to a subterranean puzzle. The real question is, will you know exactly how to read those clues, or will you accidentally drown the victim? Trust your diagnostics and ask yourself, how many of your past plant failures were actually crimes of moisture imbalance? Thanks so much for joining me for this explainer.